Hi dear students, in this video we are going to study about matrix multiplication. In matrix multiplication we have one important criteria. The first one is here it's written, if we have m times n matrix, then the second matrix n times p, another matrix it should be, which means that the column number of the first matrix should be equal to row number of the second matrix. With respect to this rule, if the column numbers and row numbers are different here, firstly the column number and then the second row number, they are different, you cannot multiply the matrices. As you see here, here m times n times p, then if they are equal we can multiply. And the resultant matrix, by the way, it's also showing that one here, resultant matrix, it should be m times p. Here there is one example for that one. Let's say the dimensions, it is not given, but all the entries in the row intersecting all the entries with the number of all the entries in the row is intersecting with the number of numbers in the column, which means that corresponding terms, which here first term and first term, second term and second term, we are going to multiply. So 1 times 1 we are multiplying only, 3 times 4, not 1 times 1, 1 times 4, it's not going like that. Only we are multiplying the corresponding terms, which means 1 and 1, 3 and 4, 2 and 2. And we are adding them, these multiplication results, and we are finding where it is written, if it is ith row and jth column, so the result should be written to aij, the row and column, it's here. And as you see, 1 times 1 here written, 3 times 4, then 2 times 2. The sum makes 17 and it's written in the multiplication matrix. To explain this one, I'm going to show one slideshow here. Presentation, PowerPoint presentation. Here, 2 matrices, 2 by 2 matrix here and 2 by 2 matrix. So result should be 2 by 2 matrix. And as I explained, rows should be multiplied by the columns. So these are the first 2 entries of the first row, 1 and 3. So it should be 1 should be multiplied by 4 and 3 multiplied by 1, and it's going to be 1 times 4 and 1 times 3 times 1. Okay, 1 times 4. Then the next one, what it should be here, 1 times minus 3 and 3 times 6. And again, I'm going to continue with the second row now. Second row and first column, it's going to written here, second row, first column, which is 2 times 4, 0 times 1. Then here, 2 times minus 3 and 0 times 6, it has to be. Okay, then we have finished multiplication here. We are going to do addition and subtraction operations here. 1 times 4 is equal to 4, 3 times 1 is equal to 3. So here 4 plus 3 minus 1 times minus 3 is equal to minus 3, 3 times 6 is equal to 18, then 8 plus 0 here, 2 times minus 3 is equal to minus 6, 0 plus 0 times 6 is equal to 0. So when you add them, this is the resultant matrix. It's going to be product of the 2 matrices, 7, 15, 8 and minus 6, and the resultant matrix, it should be equal to here 2 by 2. We are going to continue with the new exercise, and in this exercise we are going to multiply 2 by 2 matrix by again 2 by 2 matrix. So column numbers and row numbers, column number of first matrix is equal to the row number of second matrix. That fits here, so we can multiply, which is, I'm going to multiply here this one 3 times 1 by 1. If I multiply 3 times 1 plus 4 times 1, it should be, then 3 times 2, 3 times 2 plus here 4 times 1, 4 times 1, it has to be again, let me circle like this, and here also the second one, I'm going to write like this, and here like this. So minus 2 times 1 plus 5 times 1, and the other side minus 2 times 2 plus 5 times 1 it has to be. So this is equal to here 3 times, sorry, uh, 3 times 1, it's going to be equal to 3 plus 4, 7. 3 times 2, 6 plus 4, it is 10. Minus 2 times 1 minus 2 plus 5, it's equal to 3. And minus 2 times 2, it's equal to 4. 5 times 1, it's equal to 5. So 1 minus 4 plus 5, it's equal to 1, it should be. So here, these two multiplication of these two matrices, it should be in this form. But if you recognize something, here this matrix and this matrix, if the first one is A times B matrix, then second one here, this is B times A matrix. A and B switch their places. Let's see, are they equal to each other? And here, I'm going to do like this. I'm going to continue with this color. Here, 1 times 3 plus 2 times minus 2. And that's going to be equal to, the next one, it's going to be equal to 1 times 4 and 2 times 5, 1 times 3, and plus 1 times minus 2, and 1 times 4, and 1 times 5 plus 1 times 5, it has to be. Okay, we close this one. 3, it's here. 3 is here. Minus 4 is here. So the answer here, minus 1. 3 plus minus 4 is equal to minus 1. 4 plus 10, it's equal to 14. Here 1 times 3, which is equal to 3, 1 times minus 2, which is equal to minus 2, 3 minus 2 is equal to 1, and 4 plus 5, it's equal to 9, it should be. As you see, A times B matrix is not equal to B times A matrix in general. In general, we are telling here there are some specific conditions. If A is equal to B and if one of them is identity matrix, then they are not equal to each other. We need to know that one. Also, if one of them is scalar matrix, also they might be equal to each other. A times B, B times A might be equal to each other. Okay, let's continue with different exercise. Now I'm going to continue the multiplication of these two matrices. Here it is asking the A and B given and find the products of A times B and B times A to compare them also. Firstly, I'm going to check the dimensions, 2 times 3 here and 3 times 3 here. So the column number of the first matrix is equal to row number of the second matrix. That's why we can multiply A times B now. A times B, I'm going to write here A and B together, 2, 1, minus 2, 3, 1, and 5. It should be here. I want to change the color, more open colors to see easily. Okay, then this is going to be equal to times. We are going to multiply by 1, minus 2, and 3, minus 1, and 0, 2, and 5, 6, and 4. 5, 6, and 4 it's going to be. Okay, then if you multiply the matrices, you remember that we are going to multiply the rows here by the columns. And I'm going to do this operation one by one for each row and each column. Then it's going to be like this: 2 times 1, 1 times minus 2 plus 1 times minus 2 plus minus 2 times 3 plus minus 2 times 3, it has to be. Then this is first row, second column, and we are going to continue for all the rows and all the columns. 2 times minus 1, 1 times 0 plus 1 times 0, minus 2 times 2. And the third one is coming: 2 times 5, 1 times 6 plus, and minus 2 times 4. 2 times 4 it should be. Okay, we finished the first row. Now we are coming to second row. In the second row here, I'm going to multiply by the here like this again, and it should be here 3 times 1, 1 times minus 2, and 5 times 3. 3 times minus 1 plus 1 times 0 and plus 5 times 2. It should be. Then we are coming to last one. This is, by the way, 8 times b. It should be. Then here the 3 times 5, 1 times 6 plus 5 times 4 it's going to be. So quickly I'm going to finish this one. By the way, the resultant matrix is 2 times 3 matrix. It should be 2 plus minus 2 plus minus 6 minus 2, 0, minus 4, 10 plus 6 minus 8, 3 plus, I forget the plus sign here, 3 plus minus 2 plus 10, 15, and this is minus 3 plus 0 plus 10, and this is 15 plus 6 plus 20 it should be. So this is the last part of the matrix. 2 minus 2, 0, minus 6, this is minus 6, and minus 4, 0 plus minus 6 again, 10 plus 6, 16, minus 8, it's equal to 8, 3 minus 2, 1, plus 15 is equal to 16, minus 3 plus 0 plus 10, it is 7, and 15 plus 6, 21, plus 20, it is equal to 41. So this is A times B matrix. Here it's asking the, this is the, normally at the end of the video I'm going to say, I was planning to say this one, you cannot multiply the B times A, because B times A is not possible in the condition of here the dimensions are 3 times 3 and this is 2 times 3, and since they are not equal to each other, we cannot multiply.